So we're going to talk about the common logarithm, which is in base 10. We talked the other day about how our calculator is in base 10 only. We'll get to where we can use the calculator with different bases eventually. So what we're going to talk about is how we use the common logarithm and then another logarithm, the natural logarithm, to solve problems. So the first main thing is that if there is no base, then it is base 10. So those two things mean the same thing. And there's no base written. It means base 10. So looking at this first problem, if we want to solve this, then the first thing that we're going to do is put in base 10. So we have log base 10 of x equals 2.2581927. Okay, so then our next step to solve it is to rewrite it in exponential form. So remember this from the other day. We take our base to this power equals this number. So it's 10 to the 2.2581927 power equals x. Then you're simply going to put that in your calculator and come up with a value. And we can round to the nearest hundredth. So you should get 181.21. Okay, next page. This next example is similar to what we did the other day where we're making a substitution. You would need more specific directions or a multiple choice here. But the bottom line is we have log 4 equals m. We're finding log 160, and of course we're using it with m, which it doesn't say. So we need to relate these. We have 4, we need 160. So when I look at 160, 16 times 10, right? 160 is 16 times 10, and 16 is 4 squared. So I'm going to rewrite log 160 as log of 4 squared times 10. Then use your rule that multiplication is addition. And we have log 4 squared plus log 10. Then use your rule of exponents that the 2 comes out in front. Okay, then we're going to make the substitution. Log of 4 is m, so we have 2m. Let's talk about log 10 for a minute. If we wrote it with a base, we'd have log 10 of 10. And we can set it equal to x. So we would have 10 to the x power equals 10. So that would mean that x equals 1. Whenever the base and the number of the log, right, if you're taking the log of 10 and the base is 10, whenever these two numbers match, it's always equal to 1. Because if you have whatever number to the x power equals that same number, it implies, right, makes sense that it's got to be 1. So if it were log base 3 of 3, it would equal 1. If it was log base m of m, it would equal 1. Okay, so you want to notice that because that's going to happen sometimes where you need to remember that. So over here we have log of 10. So that would just equal 1. So we have 2m plus 1. For the next problem, f of x equals log of x, find f of 100. So this goes back to your function notation that you learned in 9th grade. Okay? Find f of 100 simply means plug in 100 for x and tell us what y is or what f of x is. It's your input value. Put that number in and give me the answer. So f of 100 is log of 100. Now we're not going to use the calculators, even though obviously you can because they're in base 10. I just wanted you to recognize some of these rules and doing it without a calculator for now. So we can rewrite log 100 as log 10 squared. And our power rule says that 2 comes out in front. And just like we did above, log of base 10 of 10 is just 1. So we get just 2. Let's go to the next page. Next example, log of square root of n over 1,000. So square root is 1/2 power. Our power rule says that the 1/2 comes out in front. And our division is subtraction. So we have log of n minus log of 1,000. Log of 1,000 can be written as 10 to the 3rd power. 3 comes out in front. Log of 10 is 1. So when we have log 10 to a power, it simply is that power. And you can leave it like this. If you distribute, you get 1/2 log n minus 3/2. Either one of those would work. So the last part deals with the natural logarithm. So basically, a logarithm is something that someone invented in order to help us solve problems. Like if we had 3 to the x power equals 7, we don't know what x is, and it's not a whole number, and so we need a way to figure that out. And we can keep doing like a guess and check, and we can get it, put in a decimal point and keep going, figuring out what it is. Log tables were created before calculators. There was log tables so that we could figure that out. So someone invented logarithms, came up with the rules, did the proofs to make sure that they worked. So that's where logs come from. There is one particular logarithm called the natural logarithm, which is just a log. Our normal log is to base 10. The natural logarithm is base e. And because we use e so frequently, it just became its own special one that we have. So instead of doing it log base e or plugging in e, the calculator actually has a button. So if you guys look at the calculator, you have log, and you also have ln, which is your natural logarithm. If you use the second button, then above log you have 10 to the x, and above ln you have e to the x. So log and 10 to the x power goes together because log is in base 10. And ln and e go together because log of e is the same as ln of x. So if you look in your notes right here, log base e is the natural logarithm, ln x. So we would pronounce it ln x, and that is the natural logarithm. So going back to what is e? E is an irrational number. It comes from, it's actually the limit, which you guys haven't learned limits yet because that's calculus. But it's the limit of adding up the sum of these numbers. So if we take 1 plus 1 over 1 factorial plus 1 over 2 factorial plus 1 over 3 factorial and keep going forever, if you add those numbers up, that's where e comes from, which is approximately 2.71828. It's an irrational number. Factorial, remember, like 3 factorials, 1 times 2 times 3, 4 factorials, 1 times 2 times 3 times 4. Okay. So if you add all of those numbers up and keep going and going and going, you get closer and closer to this number e. E is a special case because it occurs frequently. It's like a natural growth function. It occurs often enough that we gave it its own special name. And because it's irrational like pi, instead of trying to write out a number that you can't write out because it's irrational, we give it a symbol. Your calculator is programmed to have that number in it. But just like pi, we kind of abbreviate to 3.14. E is 2.71828. Okay? All the rules for logarithms that we had, all these power rule, multiplication is division, or multiplication is addition, division is subtraction, all those same rules work with ln. Because just remember, ln is a logarithm, it's just one particular case. Okay, so this is a graph that shows you E. So E is 2.71828. So if you look up here, this line E is the number E. Okay? This graph is basically how I showed you guys the 1 plus 1 over 1 factorial plus 1 over 2 factorial. That's the same as this 1 plus 1 over n to the n power. Okay, so you can see how it's an exponential growth function if you guys go back to the last section on exponents. This is the sum. So if you look at, for example, number 4, 4 is the sum of those first 4 numbers. And as you get bigger and bigger x values, 5, you can see as we go from 4 to 5, the graph of the function gets closer and closer to e. That's what we mean by limit. It's getting closer and closer to that value. Okay? So as we go bigger x values, we get closer and closer to e. So that just is a graphical representation of what e is. Okay, so we're going to look at a few of the questions on the homework sheet. And the first one that we looked at was 17, which is log 0.002. And because it's in base 10, we can just use the calculator, so you're just plugging log 0.002 into the calculator and rounding to the nearest hundredth. The next one we're going to look at is 26. Which is log of x equals 1.3826. So this is where, when we're trying to solve this, that we are going to put in the base. So if there's no base listed, it's base 10. Then we rewrite it as an exponential. 10 to this power equals x. So 10 to the 1.3826 equals x. And again, you're using your calculator to do 10 to that power. And round to 4 decimal places. So we have 24. 13237. So if we round to 4 decimal places, it'll round up to 1324. Next one we're going to look at is 39. Is log of 45, but in the directions, we're saying if log 3 equals x, and log 5 equals y, write the following in terms of x and y. So we have 45, we need to relate it to 3 and 5. Well, 9 times 5 is 45, and 3 squared is 9. So we can say this is log of 3 squared times 5. Use your rule of multiplication is addition. And your exponent comes out in front. Then you can make your substitution. Log 3 is x, so 2x. Log 5 is y, so plus y. And you're done. All right, and the last one we're going to look at is number 51. And this one's giving us that log of a is c. So we have log a over 10. So we're going to use our rules that division is subtraction, log of a minus log of 10. Again, you want to remember that log of 10 is 1, making the substitution for log of a is c. So I basically gave you one out of each section of the homework. Your homework on that page, you're starting at 15. And doing that first column all the way to 57. Okay, so 15, 18, 21, 24, 27, 30, 33, 36, 40, 44, 48, 52, 56, 57. And as Mrs. Barber would say, later tater.